Welcome back to Nemilas MATLAB. In this session, we are going to look at fractions. And what we are doing is multiplication of fractions graphically. In this session, we are going to look at the illustration that helps us to do multiplication of fractions graphically. We need no calculations. So as you are going to see, it's a graphical method. What we are going to do is we are going to use a rectangular frame to represent a hole. That's what we should note. For example, this is a hole. 2, we are going to partition the rectangle horizontally or vertically to represent the first fraction. So, for example, we have 2 out of 3. It can be represented as this. This is 2 out of 3. That's the first representation. If we are going to multiply, that's how we represent the first. Then partition the rectangle in an alternative direction from the first fraction. So if the first fraction is horizontal, then we partition the second fraction vertically, because this was horizontal, this one comes vertical. This is the 3 out of 5. That is how we represent it. I guess you all know this. The only rule here is for a hole, we have one. We have a fully shaded rectangle. Then the first fraction to be multiplied, we have it horizontally. If it can be horizontal or vertically partitioned. Then if this is vertically, then this one is horizontally. If this is horizontally partitioned, then the next one becomes vertical. So what you should note is that the partition for any 2 fractions to be multiplied should be in alternative direction. One should be vertical, the other one horizontal. Now, we are going to look at the actual procedure, how we do it. We are now going to multiply graphically 1, that is 2 out of 5 by 5 out of 6. We are going to have them represented as follows. We're going to have them represented as follows. As you see them here, you'll find that this is 2 out of 5. This is the first fraction represented. 2 parts are shaded out of 5. Then this is 5 out of 6. 5 parts are shaded out of 6. Now what we are going to do here is we are going to pick this first fraction. Let's pick it, have it here, and then we get the second fraction, which is 5 of 6. We fit it exactly over. Now when we fit it exactly over, you are going to see those partitions. Can we count all the partitions together? Now the partitions have become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there are now 30 partitions in total. But out of the 30, how many are shaded twice? We can see this shading here, and then this shading. So the shading which is twice is in this location. As you are going to see in this location, it is this one here. And what do we have there? How many squares? 1, 2, 3, 4, 5 sections. 6, 7, 8, 9, 10. So there are 10 squares out of 30, because you see we counted the whole, which was 30. So there are 10 squares out of 30. This means we now have 10 out of 30, which is reduced to 1 out of 3. So this is how we do it graphically. Number 2, we are going to multiply 3 out of 8 by 2 out of 5. So we are having our graphical presentations as you see them here. This is 3 out of 8. This is its representation. And then 2 out of 5. This is its representation, 2 out of 5. Now what we are going to do, we are going to say, okay, let's first bring the 3 out of 8, which is here. And then we bring the 2 out of 5 and then fit it exactly over the other one. That's the very reason why we said the rectangles have to be the same size. It has to fit exactly over the other. So now let's look at the area which doubles. It is this one here, double shading. As you see it, that's the double shaded area. We can count. We have 1, 2, 3, 4, 5, 6. It is 6 out of all the total numbers of partitions. Let's see here, it is 1, 2, 3, 4, 5. And then this side, 1, 2, 3, 4, 5, 6, 7, 8. So it is 5 times 8, which is 40. So we have here 6 shaded twice over 40. And then when we reduce it, it becomes 3 out of 20. So that is the answer for 3/8 times 2/5 using the graphical method. That is how we can achieve it. Number 3 is a two-stage method whereby we are going to look at the first 2, and then what we get shall be final dealt with, as we are going to see. So the first 2, it is 7 out of 8 by 2 out of 5. So the first 2 fractions to be multiplied are these. So that is what we have. The first 2 to be multiplied, it is 7 out of 8 by 2 out of 3. So what do we have here? Equals, then we take the 7 out of 8 and then we overlap it with the 8, the 2 out of 5. So now let's look at what has been shaded twice by both shadings. So it is this one here. As we move, we are going to have it up to this point here, up to that point. So we have 1, 2, 3, 4, 5, 6, 7. Now it is 7 times 2, which will give you this is 14. So that is the partitions which are shaded twice are 14. And when we count all these, we get 40. So we shall be having 14 out of 40, which is this one, 14 out of 40, which we can reduce to 7 out of 20. So we now have 7 out of 20, which we have now to multiply with this one here. Tentatively, we are now going to work out 7 over 20, which we have obtained here, times 4 out of 7. So that is the next which we are going to work out. Now we have 7 out of 20 by 4 out of 7. So the 7 out of 20 is this one here. Let's just put it up here. We now have 7 out of 20, this one here, representation, and then 4 out of 7, which is this representation, which will equal to this, and then which is 7 out of 20, and then on top we have to fit this, and then we can count how many squares or how many partitions in total have been let's check how many squares in total which have been shaded twice or double shading. So let's count. This is 1, 2, 3, 4, 5, 6, 7, and then this side 1, 2, 3, 4. That is 7 by 4, giving us 28. So it is 28 out of, let's see, 1, 2, 3, 4, 5, 6, 7. That is 7 this side, and then this side is 20. So 20 by 7, that is 140. So we have 28 out of 140. So let's present it and see how we can manage it further. This is now what we have. 7 out of 8 by 2 out of 3 by 4 out of 4 is equal to 28 over 140, as we have seen in our graphical representation. And when it is cancelled out, it gives us 1 out of 5. Let's try to check this by calculation and see what we get. For example, what we have is this: 7 out of 8 by x out of 2 by 2 out of 5 by 4 out of 6. So we can say, let's try, we can cancel out 7. We can cancel 7 by 7. That one dies out. Here it means we remain with 1, and then here remain with 1. Then we can cancel 4 by 8. So let's cancel 8 by 4. So this is 8 by 4. So when we cancel 8 by 4, what do we get? Here at 4 we remain with 1, and then at 8 we remain with 2, because 4 goes into 8 twice. That is what we remain with. Now let's also cancel the 2 and the 2 here. This remains as 1, and then this 2 remains as 1. Eventually, when we multiply out, we'll see all the top we have 1 times 1 times 1, which is 1, and then at the bottom is 1 times 5 times 1, which is 5, giving you this answer. So I think that's the same way you are going to work out what we have been doing previously. So let's get some exercises, some numbers, and see how we can work out them. Just pause the video and then work out. Let's see. So pause the video and then multiply the following fractions graphically. We have 5 numbers. Try them out. First do them graphically and then check yourself using calculations as we have done in that last step. Thank you. We are going to later on look at further questions which we shall handle and further applications.